How are you doing?
I'm good.
Okay.
Good.
I wish that he should have been part of the presentation about McKesson. Okay.
Yeah, I was trying to figure out how I can. I'm not part of any of the meeting invite, so is
Right.
maybe later
Yeah.
on we can see how I can get added to
I
something.
think
I completed all the trainings and everything. I got
okay.
access on Friday.
Okay.
So on Friday, Saturday, I completed all the training. So let's see.
Okay. Because what happens is that because we were sharing the medical data in that meeting.
Hmm.
Almost all the doctors were there from their side. All
Hmm.
the data scientists, and senior management and everybody was there in that meeting. Okay. So, but the only condition was that people should have had done the PHI training. Okay. Only then they get that
Hmm.
tax.
Okay.
So,
I think there is uh, uh, a process. You will get access to that portal only after 7 days. So I got
oh,
onboarded on Thursday. I exactly got
oh,
access on next Friday.
okay.
When I raised a ticket with the HR, they said that it takes 7 days to get the permissions.
It doesn't happen that way.
Uh,
It doesn't happen.
and
Let
on
me
that, all these things.
let me talk to Vidya.
Weeks time. Sorry?
Let me talk to them. I think let's do it. Let me do it on Monday.
Yeah. Yeah. I mean, I can, if you want reference, I can share okay. I can share the ticket details.
Okay.
So maybe, Vidya will have some reference.
Okay. Okay. Hmm, hmm. All right, everyone. Okay. Those who are wondering that they are like, what are the discussion about? Is it something to do with? It's not something to do with the class. So both is right. He's doing the fellowship with me, and on one of the project, and it's essentially the AI project. So, and specifically applying AI in medical domain. And yeah, that's the thing. So I'm starting these fellowships with me. Okay. And would be, you know, those who are interested, just reach out to me. I would be, there are quite a few things that are coming up now after that presentation, since this recent presentation with McKesson was a very important thing. Okay. Because when I started with this project, almost everybody said that this is not possible. They wanted an accuracy of 85%, and almost everybody told me that it's not possible to achieve 85%. Okay.
Videos are sorry.
Is that is my voice clear, everyone? Shubodh, Tushar, Sanish.
Yeah, it is. It is. It is.
Okay. I hope yeah. Because there was some break in Subodh's connection, so I'm not sure. Is it me or Subodh?
No, it's me. It's me.
Okay.
I'm just changing my Wi-Fi.
Okay. I can blame you now. Okay. Anyway, wonderful. Yes. So, okay. All right. Yeah. It's okay, everyone. You can keep your cameras on. Yeah. All right. Yeah. So before the project was started, everybody was against the idea that there's not is that achieving F1 score. When you say F1 score, it means that the precision and recall. Okay. Yeah. Aman, is it okay? Like my voice is clear?
Yes, sir, you're clear.
Okay, okay. Because every time Subodh's picture is pausing, I'm thinking that's my connection. Okay. So yeah, now we approximately achieve 97% accuracy that I was telling yesterday. And that's a something very, very interesting. Okay. And now it looks like a common sense to everybody. Okay. I know achieving this is so easy and so and so forth. Further, the things that we have done is build a model, did all of the class, like basically the main work is given a document, we have to tell whether when did the radiation start, okay, or something like that. So all we did was we tried all kinds of model and then we figured out that asking ChatGPT straight away is a better idea. Okay, so we are basically asking ChatGPT that here is the document. Can you tell me the start date, end date, and this and that? Okay, that's it. Okay. And we basically kept on fine-tuning the prompt, just kept on working over and over on the prompt and and detailing it out step by step. And then it seems to work really well. Now coming back to the point is a bigger work was that given a document, rather than trying the asking ChatGPT for everything, we first built a model that classifies the document into whether it's relevant or not. Okay. And for doing that, we basically trained a model, a classifier, which says that this document is relevant or not. So we labeled the data and then trained the model, and that's it. Okay. So that's the project, and that's one of the projects. There are more projects that are coming up. The other project, which is more related to the data engineering, where one of my teammate, who is a fellow, like he was my student in previous batch. So he joined me as a fellow, and then I basically converted him into a full-time teammate, okay, a full-time employee. And that's how it's happening right now. So I'm trying to basically, right now, that's why I have launched this thing called placement eligibility test, right, for the talent hunt. And from that, I'll be picking, say, 5, 7 people more into the projects and then convert them into full-time. That is my plan. Okay. And yeah, that's what is happening actually right now. Okay. All right. Now let's start with today's discussion. Wonderful. You can see my screen, everyone?
Yep.
Yes, sir, it's visible.
Okay. All right. So yesterday we were discussing this. Did anybody try this? Try to build it? No?
No.
Okay. I think you guys should do this. This is probably the most important thing. And I was very happy. I think Nikita did it yesterday, that one. Okay. So yeah. Veena, did you get a chance to do it?
No, Sandeep. By next class, I'll do it.
Okay. Okay. So if you first generate the data or just load the data in scikit-learn, there is this library, right? Sklearn data set. Okay. So, okay. So all right. Okay. Let me see if you can. simple data set for regression. Okay. You can just, pick up any of this data set and try on your data set, try on your model. Okay. Just pick up any, make it generalized, and start doing that. Okay. Instead of generating data, that is an alternative. But first generate your data, then define a function to initialize the weights, basically initially randomly. Then build a model. What it does is it takes X, multiplies it with weights, and returns the total sum of one, right? Like Y equal to MX plus C, similar to that. Okay. And then here, then you build a squared loss, meaning given this data, what is the difference between the predicted and actual? So you ask the model to do the predicted value. So this one gives you Y predicted equals this. Okay. And right. And then there's a difference, and then we square it, and then we do the sum. Okay. That's about this. And generation of the data is pretty simple. We are saying M records n dimensions. For now, let's just say that we have only one column, okay, and one column, okay, and or should we have more than one column? What do you say? Okay, all right. So start with n equal to 1 by default, okay, and meaning only one feature, X. And let's say my capital X is NP random, and I'm saying M comma. Okay, so it generates those many X, and then I'm saying Y equals capital X into, okay, let's say, okay, so essentially I'm saying, right, that, okay, I'm just generating data. Let's say the X1, X2, X3, right? And I'm trying to generate some sort of model, okay, and so we generated this X, okay, and now I want to generate, let's say, weights, okay, some random equation I'm generating, okay, np dot random, okay, let's see, okay, now I want to generate something like between 100 to 200, like integers. Okay, so let's see. Okay. All right, let's code one thing at a time. I think this will be a good. Okay, so what we want to do, everyone, is that we want to generate the data such that, let's say, our equation is, y equals to underneath, let's say 100 x1, 100 x1, 200 x2, and let's say 304 x3, and plus, and so on, right? And then there is a constant, and plus some constant. Okay, so what we have to do is generate these coefficients randomly using NP random. Okay, so how do you do generate random rand int? Okay, let me see. I really do not know how to do this, but let's see. Import NumPy as NP. And what do we want to do is we want to generate these weights. 100, 200, 300, 4, like that. So we want to just generate some sort of weights. And okay, so I want to generate n plus 1. So there will, if there are saying n columns, so there x1, x2 up to xn, I want to generate one more, the last one. Okay, and that's about it. Okay. Also, I want to whatever x value is there, I want to add one to it. Okay, I'll explain to you why. Right. So what I want to do, I want to generate some random values. Okay, it says random, exponential, logistic, multinomial, normal. Looks like this is my, okay. So it says that low, high, and so on. So we can basically just generate using this. Okay. And we can say, let's see if it says low, high, size, and so on. What does these variables mean? So np.random.randint returns random integers from low and high, return random integers this, and so on. Okay, let's see. Okay, and here we are saying 10, 20. Let's say I want to generate 5 integers. Okay, so it generated 5 integers. You can see it generated 5 integers. Now we are saying we want to generate data. So we first chose x1, x2's values. Okay, and we are, let's say we also want to generate the coefficients. Okay, we want to generate coefficients. Okay, coefficient. This is our secret equation, okay, that we are not going to tell anyone, okay, and we just want to keep this published, okay. We want to just keep it printed somewhere so that we can see what happened, okay. Also, here I'm going to just say np.random.seed 10 so that in case we do not know what were our coefficients, we can again generate it. Okay, so I'm just want to be very clear, because once we have generated data, then we'll train our model. Now this model will try to predict these coefficients from the equation, like it was 100, it was this. Then we would like to match it with what we have actually put in. Okay, we'll like to match in what we have already done. Okay, so let's see. Right now, is this clear? np.random.randint generates in this range, right? So what I'm thinking is, from between say 10 to 200, I will generate, let's say, n plus 1. N plus 1. If n, let's say we chose a variable with n columns. So I'm generating, let's say n equal to 5. Okay, I'm generating one more than that. You see that? And these coefficients are between 10 and 200. Okay, and I'm also setting the random seed. Okay, random seed, just to ensure that every time you call this function, it should generate the same data. Okay, it should generate the same data, just to ensure that tomorrow when we basically match up, we should not say, oh, we don't remember what was the coefficient. Okay, and just to ensure, just to fix the match. Okay, I hope everybody's okay what I'm trying to do now. All right, so I'm just putting it here. Okay, now let's see. So if you what we are trying to do is we are trying to generate the coefficients. So these are the coefficients. Okay, and we have also generated we are also generating x. Let's see. Let's say okay, n is equal to 5, and total number of records that we want to generate is 100. Okay, let's see. All right, so this is how it looks like, the value of x. Okay, these are the value of x's. Okay, and basically each experience. Okay, so value of x is this much, and then from this we will calculate the value of right. We will calculate. We will add the 1 to it. Okay, we'll add 1 to it, y. Okay, so what we are trying to do again, everyone, what we are trying to do, we are trying to generate data. Okay, we are trying to generate data. Yeah, all right. So the plan is this. Okay, the plan is this. We have x. Okay, and let's say we generated 1, 2, 3, 4. We also generated coefficients. Let's say 1, 2, 3, 4, 5, or let's call it 10, 20, 30, 40, 50. We generated the coefficients. Okay, and we are generating the value of x. Let's say this is 2, 4, 5, 6. Correct? 4. Yeah. So here m is equal to, let's say, 2. These are 2 examples. Okay. N is equal to 4. Correct? Now, what will be the value of y? We'll say, okay, take the value of x, multiply it with coefficient. Okay. Put like x comma 1, right? Put one more value here. Okay. So that this we will generate this way. Okay. We'll generate this way. 1 times 10 plus 2 times 20 plus 3 times 30 plus 4 times 40 plus 50. That's the value of for first this is our, and some random number. Okay, some random number. Then y2 will be 2 times 10 plus 2 times 20 plus 4 times 20, right? 5 times 30, 6 times 40 plus 50, right? Plus some random number. Okay. So what are we trying to do, everyone? What are we trying to do? We are essentially generating data. First, we generated the value. First, we just generated coefficients. Okay, these coefficients, right? Like the way we generated for y equal to mx plus c, we randomly. Is everybody okay with this?
So the C is weights here, right? Coefficients is same.
Coefficients, yeah. Okay. So basically, what we are generating the data is y equals to 10x1, 20x2, plus 30x3, plus 40x4, plus 50. This is our secret equation. Okay. If the kev, right? So we basically are essentially, this is our secret equation. Some random number, a little bit random number. This is our secret equation. Using this, we are generating the data points. Okay. And then we will, once we have generated the data, then we will use our gradient descent to do the random, all the work. Is everybody okay?
Yep.
Yeah. Everyone? I do not hear everyone. Okay.
Yes.
Yes, indeed.
Okay. Okay. Keep your cameras on. I think this is better. I feel better. Okay. I kind of, feel that the moment you see all the maths, you probably are not even around the computer. Okay. So, okay. All I want is that I want everybody on the same page. Okay. What the exercise we are doing right now is something that would help us learn NumPy. Okay. And essentially, this exercise is much more powerful than going in a linear way. We understand that NumPy is nothing but an array, and we are fiddling around with the array to make sure that that we generate the data. Okay. And we're going to implement the gradient descent using this one. Okay. And the first step is we generate the data. Afterwards, we will build a simple model which takes the weights and which takes the value of x1, x2 and gives us the value of y. Okay. And okay. So yeah. Or better thing is first we build the model, right? And then we generate the data using the same model by giving it coefficients. And then we let everybody use it. Okay. So yeah. So at the end of it, what we have to do is generate the coefficient, generate x, generate y, and then generate y, and then essentially let it um come up with the answer. Okay. All right. Let me just see if we can do the rest. Okay. Now, okay. So we have so what we did was we generated the weights. This is our coefficient C. Okay. And we are defining, let's say m is equal to let's say 10 instances, 5 columns or 4 columns, let's say 4 columns. And these are our coefficients. Okay. All right. Now I don't have to touch this part. Let it be like this. And then we are saying generate some data for X. Okay, we generated the data for X. Looks good. 10 instances. This is one instance of value X and so on, right? Now what we have to do is we have to calculate this multiplied with 19, this multiplied with 135, this multiplied with 25, this multiplied with 74 plus this. Okay. So what can we do about this, right? One thing we can do is there are two ways. One is we take the coefficients. Okay. We'd say, give me all rows. This is how you extract all the rows, but the columns up to -1. Okay. Columns up to -1. Okay. 0 to it doesn't let you do that. Okay. 0 to how many? Give me only the okay. What? This is my sorry. This is X. Okay. What I want to do is okay, let's say C. So this is my C. And I'm saying, give me all the coefficient except for the last one. Okay. So it gave me all the coefficients. Now I can multiply it with capital X, and then I can add the last one. Okay. All right. How would I ever know that I have done a good job? Okay. All right. Let's see. Let's see if this is correct. Okay. This. Okay. This and this. All right. Now this won't work like this. We will go slowly. We'll say this multiplied with 19. This multiplied with 135. This multiplied with 25. Yeah. And remove this. This multiplied with 74. And this is okay. Oh, I will add all of the values. Okay. All right. All right. If I did not add the value, will I get the correct answer? Okay. Doesn't look like I did a good job. Okay. All right, let's see. Okay. So this is a correct value, right? This is a correct value. So I'm going to just do a summation of these values. Okay. np.sum. Okay. So this is good, right? This is good.
So why? So it is also rounding off.
Sort of. This is strategy because we just copy pasted numbers. So some of the digits are gone. Okay. So our method is rounding off. Good. So the same thing, we took the 0th row, okay, multiply with corresponding numbers, okay, and added the last one, right? Here what we did, we first chopped off 123 from this, okay? We chopped off 123 and then what we did was we basically uh, we basically did the summation, right? Did the dot product. Dot product is nothing but this multiply with this multiply with this multiply with this multiply with this. Okay, everybody okay with the dot product? Dot product is nothing but if you are saying dot product of two vectors, a comma b dot product of b comma c, c comma d, it is equal to ac plus bd. Okay. Okay, everybody okay with this so far?
Yes, sir.
All right. So here we learned that we can do this, right? Now, what if I don't put this 0? Will it do the job for all the columns? Let's see. Yes, for the first one, it has done the job. So similarly, it must have done the job for rest of them, correct? You can see that all the values seems to be greater than 123. It has kind of added 123 everywhere. Okay. Make sense to everyone? Okay. You can see that if you don't do this, basically, this is called broadcasting, right? So what we have done is we had, let's say, one array. Okay. Okay, let me show you this way. 1, comma 2. Okay. This is one element. And then we had another one, say 3, comma 4. Okay. So we had two-dimension array, right? I'm just taking a simple case. Okay. Ouch. This is my first array A. Okay. A. And I'll just convert it into NumPy array using this. I'm just trying to make sure that all of us are on the same page. Okay. So feel free to ask the questions. Okay. Let's say this is 10, comma 30. Okay. If I say A dot B, what it is going to do is, it will take this, multiply with this, okay, which will be how much? Let's see, 10 plus 60, which is 70. Then it will take this and multiply with this, which is how much? 30 plus 120, right? Am I making sense to you? So 1,2, which is 1 times 10 plus 2 times 30 is equal to 70, correct? And 3,4, 3 times 10, 4 times 30 equals to?
Isn't dot product row into column?
Meaning row, column, row, column. No, that's a matrix multiplication. That's a matrix multiplication. Are you okay?
Okay. I mean, okay. My understanding of dot product was row into column.
It is row into
Okay.
column, right? It's
What?
true.
Yeah, dot product is row into column.
Yeah, this is also row into column only, right? First row is 1, 2. And in the second array, the column is 10 is the first column and 30 is the second column, right? It's
Yeah, it's the same thing. I think, let's see. This row times column, okay, which is how much? This is 10 plus, then we take this one and multiply 3 times 10. And then first one is basically same thing, 30 plus, and then
No. I think what Veena is
this
saying
is
is
wrong.
true. If you add on line number 5, if you add one more row, then our calculation will be wrong. Here we have 10 and 30 as different rows. I think what Veena
Yeah.
shared is right. I got it. Okay.
Okay. So see, what it does is it kind of does 1, 2, 3, 4, and the dot product with 10, 30, 10, 30. Okay. No. Okay, no. Not like this. So what's happening right now, the way I'm looking at it is this. Take this, do the dot product with this one. Take this, do the dot product with this one. Okay. So basically 1, 10, 2, 30, that's 70. 3, 4, and then 10, 30, that's 150. Okay. You can test it more. Let's say 1, 2, 3, 3, 4, 5, and I'm just putting, let's say 10, 20, 30. Okay. So, okay. So what's happening here is that basically this vector is getting multiplied with this one. This vector again getting multiplied with this one. So this is called broadcasting, right? Since this has 2 rows, but this is only 1 row, so this row will be copied to both the rows, and then the multiplication will happen, right? This phenomena is called broadcasting. Okay, say for example, you have 1, 2, and you say 4. Okay, so it'll convert this, not like this. Okay, if you have NumPy, we are talking about NumPy. Okay, and we say multiply it with 4. Okay, so what happens is this is same as doing the NumPy array of 4, 4. Okay, so it broadcasted the 4 twice. Okay, so if let's say it was 1, 2, 3. Okay, and it would give us this, and okay, sorry. Okay, so you can see that this internally is doing this. Okay, this internally is doing that. Got it? So this is called broadcasting. It broadcasted 4 into this until it matches this. Okay. Make sense, everyone? Just to match the number of columns. Okay. And if let's say we were multiplying with let's say np dot array. Okay, let's say further, okay, further we take this, okay, and we have, let's say here, multidimensional array. Okay, this is my multidimensional array. Okay, now you see what it did was it basically did the job of like multiplying this twice. So this second part got kind of repeated, okay, like this. Okay. Did I make mistake? I forgot one.
No. So
Okay. So what you see is here 4 got broadcasted internally into 4, 4, 4. Okay, as if it's a array. So 4 got multiplied to all the values. Okay. Now here this one has 2 rows and this is 1 row. So this 1 row got copied twice internally as if there are 2 rows here. Am I okay? Everyone? Pratik, I'm not able to understand anything. Are you trying to say something? No, it's like very breaking. Just guessing what's okay. Try changing the mic or something. Is it garbled for everybody else?
yeah.
Yeah.
Okay. All right. So yes. Yeah. Subodh, you were saying something. I interrupted you.
Yeah, I think if we change the on instruction 45, if we change the lower values, say 4, 5, and 6 in the second row, we make 4, 5, and 6.
Mm-hmm.
It will impact the second row, right?
Yeah. So what I wanted to show you is that this, let's say this was 4, 5, and 6. Okay. And right. And this basically is getting copied twice. Okay. So let me just put it 4, 5, 6. Okay. And 4, 5, 6. So it's essentially like this. So or let me just okay, just to as a separate demo, I will say this is 40, 50, and 60. Okay. So what we'll do is this got dot product with this one. This got dot product with this one. Okay. Make sense, everyone?
Yep.
Okay. If we here, okay, instead of doing dot product, we could also say A into B. Okay. What it will do is it will not sum up. It will just give us this multiplication. This row multiplied with this row, which turned into 10, 40, 90. Then next row multiplied with this one, which will be 30, 80, and 150. Make sense? And we could say here afterwards, we could say np dot sum a star b, okay, and we'll say access equals 1. You see this? So this is the first access. Okay. If you say x is equal to 0, what it does is, okay, it basically does it column wise, 3 plus 20, 80 plus 40, 90 plus. So if you say x is equal to 0, it does that. Everyone okay so far? So instead of saying a dot b, we could also say np dot sum a star b, and then we are saying x is equal to 1. Make sense? So you don't have to iterate over these values. You can simply use this dot product or multiplication of vectors. You see that how it eliminates the need of writing loops? Are you able to feel it? Otherwise, we would do the looping things again and again. Everybody okay?
Sir, I want to ask something.
Yes, Aman.
So there is also one command that we write np dot dot a comma b
NP?
dot, then we write dot dot, yes, a comma b.
Yeah, the same thing, right? So same
Yes.
thing. Same thing. So
Okay.
if, yeah, same thing. Okay. Cool. Either you say a dot dot b or you say np dot dot a comma b. It's the same thing.
Okay, sir.
All right. Perfect. Good. Good that you brought it up. Now, is everybody okay what we did? We basically have coefficients, an array containing coefficients. We want to multiply, we have an array containing coefficients. We want to multiply each value with this array, and then we want to do the total, and that's it. Correct? And then we also want to do last value in this coefficient. So C colon 0 means give me all the values. If you have, let's say C is this, okay, C is this, and we want to say C, give me all values. It'll give all the values. If we say start from 0 and go up to the last element, but not including the last element, that will be -1. Okay, we could also say, okay, from using shape, we can find out the length of this vector. So right now we found out the length of the vector is 5, and we can say, C, give me from starting 0 colon this -1. Okay. And oh, sorry. Okay. So the shape is a tuple, so we have to use this sign. Okay. So we are saying this is the length of the C, and we are subtracting 1 from it. So starting from 0 up to the length -1, we are reaching this. Okay. And that's it. So instead of doing this format, we just said C -1. Okay. It's also the same thing. Okay. You can see, if you don't believe me, you can say -1. Okay. So both this and this are the same thing. Everybody okay so far? So we have coefficients list. We want to remove the last one because last one is something that we want to add, and these things we want to multiply with x, and that's about it. Okay. The other thing we could have done is we could have added 1 to x and then just added c. That could have been even further easier. Let's see if we can do that.
Yes, Sandeep.
Yes.
Line number like 60 and 659, we have the same thing do by the different thing, different operator.
Which one?
60 and
This?
59, yeah.
Yes, that's correct.
But any difference in both of them? No difference, like the memory consumption or the utilization.
I don't think so. I don't think so.
Then why?
Because this.
Yeah.
Go ahead.
One more thing, by the length method, we can do the same thing also.
Yeah.
That's why the one thing
So
do
instead of using length, use shape. Okay?
Okay.
Because length let's say capital X, right? This is your X, right? If you say shape, it gives you all the dimensions.
Okay.
Okay. So when you deal with the vectors, since they could be multidimensional, use shape.
Shape.
Okay. Perfect. Very good. Now, what I want to do is I want to, instead of doing this, like, slice the last one, I want to add 1 to all the values of X. In the end, if I just insert one more value, that should do the trick, correct? So can I say an X dot stack? Okay. And what would be a good way to generate that? NP dot to 1. And what's the size that I'm expecting? I'm expecting the size of n comma 1. Okay. Will it work? I don't think so. Okay. Let's see. So here, this is my X. Okay. And the shape of X. And if I say np dot 1, and it generates ones in this np dot ones, is it? What is that? Okay. I think it would, yeah. So it generated this, okay. X dot stack. How would you concat these? Okay. Let's see. Can I how should I? Basically, I want to add one in the end of all of these. What would be a cool way of adding 1 to it? Okay, let's see if I can use a method. Let's say this is ones. Okay, I generated ones. Fine. We have lots of ones, and we want to do is np.stack. Okay. I remember it was okay. Yeah, it did not work.
Sandeep, I read about B stack or H stack.
No, what? B stack.
Yeah, B stack or H stack.
H stack is there. Okay, let's see what it does. Stack arrays in sequence horizontally. Okay. And okay.
Same B for vertically, something like that. V for when.
Also V stack, okay.
Yeah, V for when.
All right. Let's see. Okay. Stack arrays in sequentially horizontally column wise. Okay, let's see what it does. Let's say you have 1, 2, 3. It will basically just stack this. This is what I want,
Yeah,
right?
yeah. Horizontally. Yeah, yes.
We have 1, 2, 3. Yeah, this is what I want. So if I have X and I have X and I have ones, takes a positional argument, but 2 were given. Okay.
Yes.
All right. Cool. Now, basically, I added 1 to it. You see this? All right. So I could just, okay. So this is coefficient, this is X, and coefficients are 1 more than X. And what we are doing is we are saying np dot X. Okay. We added 1 to it. Okay. And then, all right. Cool. So we generated 1. We generated 1, added to it, and that's about That's about it. Okay. Okay. Now we could also define something called a model, which takes X and gives out Y, which takes X and weights. Okay. And what it does is it returns Y. Notice one very important thing I want to show you. X is two-dimensional matrix. Okay. Therefore, I'm using it as a capital word. Okay. While my coefficients are one-dimensional, so I'm using them as a small letter. So that's a general understanding in machine learning word. For matrix, we use capital. For vector, we use small case. Okay. So X is a matrix of m cross n rows, m rows and n columns. C is a vector of n plus 1 values. And we are saying we basically keeping this way, right? Now, I want to define a model which takes X values and generates the Y value. Okay, how does it do? X times W, and it would return, okay, it would return this. Now, I want to just add one to it, one to the X values, okay? Or should we just leave it like this? What would you say? Okay. This is what I'm trying to do. Okay, how about we say np dot stack. Stack is what we did, right, just now? Okay. Okay. I am saying this, and before that, what we did, we generated this, correct? We generated this. Okay. Now we are saying generate these many ones. What is M? M is nothing but x dot shape, and we are picking the rows from the X. Okay, so what we have done, we have added one to it, right? We stacked onto this. Okay, and that's about it. Good. So it takes capital X and the weights, it adds one to it, and then it does the dot product. Are you guys okay with this?
Sorry, what is this x dot shape 0? I missed it.
Okay. So X, let's say this is your X, right? This is my X, it has got rows and columns. Okay. If you say X dot shape, okay, it would return the dimensions of it. Okay. So it has got 10 rows and 4 columns. Okay. From this, I'm saying pick the rows, which is 10. Okay. Generate a new matrix containing 1, 1, 1, 1, 1, 1, and then appending that 1, 1, 1, 1, 1 like this here, and then doing the dot product. Good. No? Not happy? Okay, let me show you. Okay. So imagine our weights are this. Okay. 10, 20, 30. Okay. Our values of X is 1, 2, 3. Sorry, 1, 2, 2, 3, like this. And what will our model do is it'll take X and weights and it'll generate the value of Y, right? How it's generating the value of Y? So it is doing 10 of X1 plus 20 of X2 plus 30, correct? So when it put this value 10 times 1 plus 20 times 2 plus 30, correct? And then 10 times, then it's adding 2, 10 times x1, which is 2, 20 times 3 plus 30. Are you okay with this? So our model is taking the x and the weights, the coefficients, and generating the value of y. Are you guys okay?
Yes.
All right. Or let's say we call it predict. Okay. Predict y. This is better. Okay. Happy? So given x and weight, it gives the y. I like the word model. That's much better. Okay, sorry guys. Okay. Everybody okay? So our model function is working fine. Okay. Give me some sign that you all are on the same page.
Yes, Sandeep.
Okay. So this is my model. Okay. And what it does is it takes x and w, gives me the value of y. That's it. Okay. Now, what I've done here is the generate data method basically first it generates the coefficients, then it generates x, then using that, it generates the value of y. Okay. And value of y are going to be random values, right? Right, I'll add some amount of randomness to it. Remember that 5 times, or let's say 3 times random, right? We'll say np dot random. How many rows should it be there? Should be there m rows and 1 column. Okay, 1 column. Okay. All right, and then I'll just subtract by some other values, np dot random dot random. Okay. All right, should I just keep it a little lower? Just 2 and 2. I'm just being a little kinder. Okay, is it okay now? Good. Okay, I'll also do a
Okay.
print of coefficient, okay? So that we can see later that where's the mistake? Can anybody help? np dot x, okay? We'll just say model, we'll pass x and c, and that's about it. So we said model x and c, it generated the y predicted, and then I'm adding some amount of randomness to it. Okay, np dot random, and then np dot random. Okay.
One bracket,
Awesome.
I guess, at the end.
Oh yeah, thank you. All right, done. This is good enough, right? So let's see if it works or not. We're saying generate data, 10 records, 2 columns. Okay, so oh wait, I did not return x, right? Okay. All right. So it generated this data, right? So 10 times this plus sorry, 19 times this. Okay, let's just test it out if it is correct or wrong. Okay, so 19 times, so it generated these coefficients. Okay, 19, 135, and this plus 135 times this. okay, plus 25. Okay, so you can see here it's 137, right? And then there is some amount of randomness added to it, correct? Okay, so for this it has generated these values. But why didn't it sum these values? It should have summed it, right?
We are subtracting also, right? It's adding and subtracting. So
Mhm. So this is my X, correct? I'm saying give me 10 rows, okay? And then when I say here, okay, when I say here, oh, here I made a mistake. I should not say this, okay? I should just say M, and yeah, this is better. Yes, now it's better, okay? So it generated these coefficients. Notice that it generated the same coefficients again, right? That's the power of fixing the math. Okay. All right. I hope everybody gets the feel of seed. Now, every time we do this, it will generate the same data. Okay. All right. Okay. Pratik, I can't hear you at all. There is just noise that is coming. Okay. And all right. Now, everybody okay, right? So we were able to successfully generate data using NumPy. Happy? So we designed our model function, generated data. Okay. All right. Okay. So let's also generate the write a function for data loss. Okay. All right. Or let me just do the training right away. Okay. Let's see what all do we need. First of all, generate data. Correct? Generate data. And let's say I'm generating 1,000 records with, say, 4 columns, four features. Okay, 4 features, and I'm just generating m cross m. Happy? Now what I'm going to do is, okay, what I'm going to do is, this is my x and y. Okay, this is in my x and y. Now, what are we going to do? We are going to, assume some value of weights. Okay, we are going to say initialize, or we are going to say np dot random dot random. Okay, how many weights do we want? N plus ones. Okay, so those are my weights, small w. Notice the things. Okay, is that Rahul? Rahul?
Yep.
Okay.
Sorry, I
Your
was
voice is
mistaken.
clear. Your voice was clear, but there's some sort of noise that comes in sometimes. Okay. Now,
Yeah, I'll pause also.
Okay. Yeah. Keep talking. I would say keep talking. At least give me some sign that it's working. For me, when nobody is responding, I feel that, okay, I've lost you guys and you are not
Yeah.
with me. Okay. So keep giving me sign. Now, what are we going to do is we are going to, number one, assume some weights. Okay. And then we're going to say, we were going to randomly generate the weights. Then compute gradients. Okay, compute gradients, and we are going to pass the loss function with, we are going to pass the loss function with these values. Okay, so this is my loss function, and we are computing the gradients. We get the gradients. Okay, once we get the gradients, what we do is we say w minus equal to, okay, eta times gradients. Okay, and we run it in a loop. Okay, we will run it in a loop. Okay, all right. And we can basically say this way that define, okay, what you want to do is fit. Okay, fit takes loss function. It takes capital X, capital Y, small y, the initial weight, and okay, and also it just keeps printing the loss. Okay. Okay. All right. So this is what we're going to do. And fit as in, right, we'll just say run it epoch times. So we'll say for I in range number of epochs, and that's about it. Happy? Okay. That's it. That's your gradient right now here. All right. Now,
Define the eta.
yes. So generate data, we are done, correct? And we don't need to do anything here. Now, initialization, we don't have to do anything. Fit, okay. So fit is something that we need to work upon. So first we define a loss function, okay. We define this loss function. It takes X, Y weights, okay. And it returns what? First, it calls the model, okay, on X. This is the predicted value of Y. It generated the differences. Then it did was np.sum diff square. Okay. Now, since X is going to be right, so this difference is going to be I mean, yeah. So this difference, so this will return an array, like a one-dimensional vector. This will be a vector. When you square it, it will be a vector. So for all the instances, it is going to compute the error, and then we are squaring it, and then we are summing it. So this should be good enough. Okay. So yes. All right. Now we can test it out. Loss function, if we, let's say, this is my W, okay, this is my W, and we are saying this is my loss function, and then this is my X, this is my Y, and this is my W. Okay, where did we generate the data? So let's say X comma Y equals this. We generated the data, then we computed this. Okay, we are making a mistake. And what's happening here? Okay, so what's happening here is that this model is not, shouldn't it add one to it? Okay, help. Oh, here. So it takes X and W. Okay, I'm passing X and I'm passing W. And okay, let's see what's happening here. X dot shape, W dot shape, and Y dot shape. Okay, so X is 10 rows, 2 columns. W is, oh, that's a mistake. What am I doing? Sorry, guys. I will. I will again do it. Yeah. Okay. I'll delete everything from here. Okay. I'll just do it in parts. Okay. So we can delete everything else, right? So we have defined model. We are happy with it. Okay. And yeah, all of this thing is just for the explanation sake. Okay. So we got our model. We got the generate data function. We got all of this rolling. And we tested the loss function. This is my loss function. Now, what I want to do is, after I generate my data, okay, okay. So after I generate my data, I want to generate data. It should generate data. Oh, generate data doesn't take n comma n like this. Okay, so x and y I have generated. Now I am saying loss function. This is my x. Okay, before the loss function, I have to give my weights. Okay, I am doing the weights. Then asking loss function to check this. Loss function takes what all does it take? Where did we define loss function? X, Y, W, X, Y, W, and it computed the loss. Good enough loss, right? Now, so our loss function is ready. Now we do the compute gradients. Okay. Okay. Compute gradients. Compute gradient takes the loss function X, Y, W. Good. Who will help me write the compute gradients part? Okay. Compute gradients will compute gradients of this loss function with respect to each of the variables. With respect to each of the variables, okay? And it'll just increase each of the x values, sorry, each of the w values, tiny bit of the values, and then compute the rate of change of loss. Okay. So, okay, this is going to be interesting. So what are we trying to do is, we will basically, we will increase the w value little bit. Okay, so we will say loss function, okay, on x, y, and w, right? That's what the loss function is. Okay, let's call it L1. Okay, that's my previous loss. L2 is loss function x, y, and w, let's say 0. Okay, once we have modified the value of w, let's say one value of w by, say, tiny bit of delta. I'll just call it delta. Okay, delta. Or can we just say, okay, does it work like this? Let's see. Okay. Yeah, it does. Okay. Yeah. Yeah, it is working. So we'll just use this kind of annotation. Okay. We'll just say 1. Yeah, this is better. If I say this, it just throws error. Okay. So here you can see we have, this is the delta we are defining, right? What we're going to do is, think for a moment. So what we're going to do is, we are going to go over all the values of W, and one at a time we will modify the value of W. Correct? That's what we are going to do. Are you guys okay with me so far?
Yes.
Okay. Now if let's say, and right, so let's say we have 1, 2, 3, my value of X and Y, and this is 2, 3, 4. That's my value of, this is X. Okay, this is X. This is first instance, second instance, right? Now our, let's say W looks like this: W plus 10 plus 20 plus 30. The W is, let's say, 10 plus 20 plus 30 plus 40. Correct? So first time we want to do the multiplication of all of them, right? That's what we want to do for the first time. Okay. Now the next time what we want to do is we want to just increase. Okay, what we want to do is 1, 2, 3, 10 plus delta, 20 plus 20, 30. Then what we want to do is okay, and then for each of them, for each of these values, what we want to do is we want to basically compute the rate of change for each of the value. Correct? Let me put it the other way. So this multiplied with this, okay, and at the same time, what we are trying to do is this 1, 2, 3 multiplied with 10, 20, 30, 40, 10 plus something, then 1, 2, 3 multiplied with 10, 20 plus something, 30 plus something, like that. And then we'll get this value. Then we have another value. And then from each of these values, what are we going to do is we are going to subtract this initial value and compute the rate of change. Okay? Okay. Are you guys okay? No.
We are increasing the weights one at a time. Like first
One at a
one
time.
we'll
Yes.
increase and we'll find it, and then second column, like that.
Yes. Yes. Okay. Let's take a look.
So, I mean, we will do one weight at a time, but how
Yes.
will we iterate? I mean, will we take the loss? I mean, we'll evaluate the loss one weight at a time, or will evaluate the loss? I mean, right now we are doing one weight at a time, but
Yes. Yes.
our aim would
10,
be to do it
20, 30, 30 plus delta, then it'll be 10, 20, 30 plus, then 40 plus delta, like that, right? And then once we have this, right, we should be okay. Now, here is a very simple trick, okay? We can generate a new matrix with that diagonal, a diagonal matrix, and then add it to the weights. Let me show you what I mean. Let's see. Okay, so np dot diagonal matrix. Okay, so okay, let me see. np dot diagonal matrix. Okay, what does it mean? Okay, extracts a diagonal or constructs a diagonal array. Okay, so returns a specified diagonals np dot a range. This, if this is your, no, okay, what we will do is instead of this, let me think, how should we do it? Any ideas, everyone? What I want to do is generate a diagonal matrix. Okay, generate a diagonal matrix. Okay, so 0, 4, 8. Okay, 0, 4, 8. All right. Will it generate 1, 2, 3? You can see,
Yeah.
right? Okay. So if we have np dot all, okay, and let's say my value is 1 e to the power 8, okay, and I think it's called np dot fill or something. Let me just see. So I want to generate, oh, there is a fill diagonal method. np fill the main diagonal of the given array of any dimensionality. Interesting. Okay, this is interesting. Okay, yes, so we got it. All right. So what we want to do is, let's say this is my W. Okay, let's take a look at. This is my W. Okay, this is my W. I will repeat it. Okay, and fill the values with that. Okay, so what is the what I'm looking for? I'm looking for what is the how many elements are there in this? Okay, um, like M, right? M. Okay. M is how much? Oh, I mean just too many. N is how much? 1, 2, 3, 4, 5. Okay. So we'll just say okay, number of weights is equal to length of W or W dot shape 0. Okay. So we are saying just generate a diagonal matrix with this. Okay, let's see how it looks like. Right. This is wrong. I will say, oh, yeah, this is good. This is good.
It is
And
good.
what was the method that we just saw? np dot
Fill
fill
diagonal.
np dot fill diagonal a with our
Well,
tiny. Okay. So let's see how the a looks like now. Oh, it did not work. Oh, I think because we have here. Okay.
Int.
Yeah. This is better, right? Yes. So I filled the entire diagonal with this. Now I can simply say W plus this and bam. Okay. Sorry. NP and I can say W plus A. Okay. So you can see that my weight was 0.91365. Okay. The here. Okay. Or let me just show you that. Okay. Yes, I added one to like first I added to the one to the first value, then second value, then third value, then fourth value, then fifth value. Okay.
but Sandeep, my weight convert to the 2D array. Like the previously is the 1D array.
Yes, yes, yes. Good observation. Right? Good observation. So what I'm going to do is instead of using the model method, what I'll do is I would I would or I can actually just do that thing still. It'll
Yeah,
still
Or
you
work.
can just take the
you pick the
each
diagonal.
row, right?
Yeah.
You can take each row.
Each row or each diagonal? Because diagonal is changed.
No,
Okay.
no, no, each row, right? So each weight will change in each iteration. One weight
Hmm.
will change in each iteration, and you take each row, and use it, and then for the next weight, use the next row. With only W2 is changed, and only W3 is changed, and so on. We can iterate through it for each row.
Right. Right. So I'm just thinking louder, right? What I want is that every every value must be multiplied these many times, correct? So what you want is so this is all good, right? Let's say for now, let's okay. So this is my W, right? We'll say new W's, okay? This is my new W's, and new W's look like this, right? Now what I want is, this is my capital X, right? I want to multiply each row, okay, with each of these. Will it work? I don't know, okay? So what I want is 0, okay, dot, new W, okay? So it says that the shapes are 4 and 5. They are not aligned, okay? Now, I'll have to kind of broadcast the first one to the second one. Okay, let's see how it looks like. Okay, this is my, right? And I'm just thinking louder what happens when I do the dot product. Okay, are you guys with me so far?
Yeah, can we add 1 to X? Because last is anyway the C,
So
right?
this is my X value, right? This is my X instance, one instance, correct?
But dimension is not same here. This is 4.
Yes,
That's
yes.
the problem.
So ideally, in such cases, it should broadcast. I want it to broadcast. Okay. So what I want to do is, I want each of the variable from the second one to be multiplied with the first one. Okay. So what I want to do is, I want to do this. Okay.
4 or 5.
Okay, let me think. Let me think. Any suggestions will be more than welcome. So what I want to do is,
We can
yeah.
we did something earlier, right? We add one more element in X as 1,
Hmm. Hmm.
right?
Hmm.
Then the both would be 5,
What
and
what
then
I what I can do is a clever thing. Okay, I can do the matrix product here. Correct. So if I do the transpose of this matrix, right? If I say new W dot T, okay, what is transpose? It converted the row into column. You see,
Yeah.
206 came in the row, and this came in the, yeah. Okay. So this is my weights. And what I'm trying to do is, for each of them, right? This is one instance. I want to do take this, multiply with this, then take this, multiply with this, take this, multiply with this, take this, multiply with this. Correct?
4 into 5. Okay.
Right? You remember the matrix multiplication?
Yeah.
Right? So if you have, let's say, 1, comma 2, comma 3, okay? And this is your first matrix, okay? This is your A, okay? This is your, right? Let's call it, say, 2, comma 3, comma 4, right? And what we are trying to do is, we are trying to do the matrix multiplication. Is everybody with me so far? This is your A, this is your B, okay? And so remember, how do we do the multiplication of numbers?
Matrix.
I'm just putting some numbers here. Okay. Yes. All right. Are you guys with me so far? Let's take a look. Okay. I'll just do np dot array, convert this into an array, a NumPy array, convert this into NumPy array. Okay. So you can see 1, 2, 3 multiplied with 10, 20, 30, which is how much? 90 plus 40. plus 10, 140. Correct? 1 to 3 multiply with 20, 30, 40, which is, this is 120. This is 60, 180. 180 plus 20, 200. Then this row multiplied with second row multiplied with first column here. This one, okay, multiply with this, okay, and that's correct, right?
What is happen if we at the rate A, like the reverse?
So this is row and this is column. So we get this, okay, right? So we get these values. So is everybody okay with the matrix multiplication versus dot product? No? Yes? Give me some sign.
Yes. Yes.
Yes, sir.
Multiplication, yes, we are aware.
Okay, perfect. Now, what we're trying to do is we have got these instances, right? Let's say this is 1, 2, 3, this is 3, 4, 5. Right?
Row into
And,
column.
and what we are trying to do is we have generated these weights, like these weights, right? After adding 1 to it. So what we're doing is first, this is W1 dot bit weight, like that, right? So what we're doing is take this, multiply with this, take this, multiply with this, like that. Okay. So after generating the matrix, what we have done is we have uh, done a transpose of the matrix so that W1 plus delta, W2, W3, W1, then W2 dot plus delta, like that. So what we are trying to do is we are just adding. So we cloned our W so many times. You see that? We cloned our Ws so many times. First, we are increasing the W1, then W2, then W3, W4. Okay. Now let's take a look. Okay. So what we are trying to do, this is our new weights after transposing. After transposing, we got, first we are adding 1 to this one. Instead of 1, we'll be adding really tiny value. Okay. 1 to this one, then 1 to this one, then and so on. Now what we want to do is take the value of X. This is my row, multiply with this column and sum it up, all of the values. That's my first value, then second value, and so on. So what we want to do is we want to do X times new W dot T. Okay. The input operand has one mismatch. Why? Because it has less number of columns. So what do we need to do? We need to add 1 to each of them. Okay. So how did we add 1 earlier? Remember how we added 1? Like this. Correct? So we will add 1 and then everything will be okay. Right? So we'll just say this. So what we are doing? We are adding, generating ones, and then we are adding 1 to it. Okay. And then we are saying X1. Yes. Done. You see that? So we have generated these many values, right? So this is the predicted value of Y for the first instance when W1 was changed. Okay. When W2 was changed as per the first instance. Okay. So this is essentially what we have done is this is the predicted value of Y. Okay. Predicted value of Y when for first instance, predicted value of y for first instance, first instance, right? Yes, first instance, when W1 was changed, for first instance, when W2 was changed, when W3 was changed, when W4 was changed, W5 was changed. Okay, these are the predicted value of y. So now I can simply say, now, okay, how am I going to do this? What I want to do is I want to subtract the predicted value of y from all of that, right? And how am I going to do that? Okay. Okay, let's see. Let's see. So question is that our y looks like this, 1, 2, 3. Okay. Y predicted looks like this. Okay. Y predicted looks like this. Right. 1, 2, and right. 3, 4. Here there are only 2 weights. So, right. So like this. So y predicted when first value was changed, it is this. Second value was changed, it is this. For second instance is this, and so on. So what I want to do is subtract one from this, and so on. Let's see how it looks like. Does it work? Okay. I will say np.array. Okay. I'm just going very slow. A lot of ideas would come in the midway. Okay. And yeah. So what is happening? Is it okay? Right? NumPy.array. Yeah, I forgot to put a comma. Yeah. Just want to demonstrate to you. Okay. So it says that operands could not be broadcasted together. Okay. So you see, for first instance, the predicted value are these two. This is when first weight was changed. This is when second weight was changed, right? For first instance, the predicted value is this much and this much. Okay. What you want to do is 1 minus 1, 2 minus 1. Okay. So if I basically put a bracket like here, will it work? Okay. It says it cannot be broadcasted. Okay. But if I put a bracket here, will it be broadcasted? Right? Yes. Okay. This one seems to work. Okay. Now, how am I going to achieve this? Where did I make mistake again? Help me, guys. Okay. Have you guys zoned out, or are you with me? Everyone? So
Yes.
what I'm trying to achieve is so these are my predicted values of y. For first instances, there are 2 values that are predicted. Okay, I have 3 instances of x, right? And for each instance, the actual value is 1. Second instance, the actual value is 2. Third instance, actual value is 3. Okay, and the predicted value for first instance are multiple. Why? Because there are multiple weights. So we tweaked first weight, observe the change. We tweak the second weight, observe the change. Okay. So we got these 2 values. What we want to do is, we basically want to subtract each value with the common one, right? And how am I going to do? If I can convert this into something like a 2-dimension array. Okay. So let's just try to do that. Okay. So this is my yy. Okay. This is my yy. I want to convert it into such that this internal becomes like a square brackets. Okay. So I'm going to say reshape. Okay. -1, Okay, and how do you, okay, I'm saying 3. Okay, no, not like this. So we'll say, okay, 3 comma minus 1. Okay, this is better, right? Or we could say, okay, minus 1 comma 1. Okay, so what we did was we said, okay, reshape this array such that the last dimension should have only one value. Okay, one value, and the first dimension can be anything. So we converted this 1D array into 2D array. Are you clear about reshape? Do you see the difference between this 1, 2, 3, which is one dimension? It is 2 dimensions. Okay.
Sandeep, can you just explain? Reshape, what are the 2 parameters, like -1 and 1? I didn't get that.
Yes. Like, say you have this. Okay. Okay. Its shape is this, right? You want to, or let me just show you the other way. Okay. Let's say you have your, right? Your array looks like this. Okay. Okay. You want to convert this array into 5 let's say into 3 columns. Okay. So you said, give me 3 columns. Okay. And figure out how many rows are needed. So it figured out 2 rows are needed. Okay. And 3 columns have been done. Good. So I'm reshaping this into 3 columns. Okay. If you wanted to reshape this, okay, we want to say, okay, let's say there are, say 6, 7, 8, 9, 10, 11, 12. There are total 12 elements in this. Okay. So if you do reshape 3, what it did, it created 4 columns, 4 rows and 3 columns. You are with me?
Yeah, got it. Got it.
Now, let's say what you want to do is you want to say, okay, put let's say 3 columns, and last one is, okay, so last one has one value. Okay, or let me show you a better way. 3, 2. Okay, so it converted this array into 3D. Okay, first dimension, it will figure out, it's like a wild card. Second one and third one we have provided. So it says that this one has two elements, and it has 3 rows. Okay, and then it figured out that it needs 2 of these. Okay, so it's like a wild card, right? If you want to say, okay, give me 6 rows and this. Okay, either we could say explicitly 6 comma 2, so it reshaped it into 6 rows and 2 columns, or we can just say figure out by yourself. I don't have time to do this calculation, right? So it figured out by itself. Correct? If I say 5, it will give an error. Okay, you cannot change it to 5 by something because this is not divisible by 5. Okay, everybody okay so far? This is a very important thing, and you will see this in interviews very often asked, how would you reshape this array? Okay. All right. All right. Perfect. So we learned about reshaping on the way. What we are trying to do is we are trying to convert this one, the predicted y, such that I can subtract from this. Okay. I'm just going to copy it down so that we are back on the topic. Okay. So we have got yy. We reshaped yy. Okay. To okay, I'm just changing it to yy1. Okay. Now I can do. So this is my predicted. These are the for each for each instance in my input, I generated multiple values of y. First I changed W1, then I changed W2, like that, right? So now I subtracted each value with the corresponding. So first one got subtracted, 1 minus 1 is 0, 2 minus 1 is 1. So you can see 1 minus, so each value, okay, got subtracted like this. So you can see 1 minus 1 is 0, 2 minus 1 is 1, then so on, so forth. Correct? Are you guys okay with this? What I did just now?
Yes. Yes, Sandeep, what is this difference called actually?
Huh?
This difference between predicted, y p minus y1. What exactly is this difference?
We'll just call it like error or difference. We can just call it
Oh,
difference.
wait. Okay, error rate. Okay.
Error, we just call it. Okay. Now what we're going to do is we are going to right? We are going to compute. We are going to compute what? We are going to like we got multiple errors. So we'll sum up this value. Okay. We'll sum up this value. Okay. After squaring it. Okay. So we'll just square these values. Okay. This is my difference. Okay. And this is how difference looks like. And okay. And this is how difference looks like. Now I can say difference square. Okay. So you can see each of the values have been squared, right? And then I'll just call it square difference. Okay. I'm just doing step by step so that we all know what we're doing, right? Now I have to sum up all the values, like the total error because of changing W1. Total error because of changing W1. That's what we have to do. So, okay. So we have to do sum. Okay. And which axis should I do summation on? NP dot sum. And we'll say access equals 1, right? Let's see. Did it work? I'm not sure. Let's just print it out. Okay. So square difference looks like 014, 149. Okay. And then this is wrong, right? No. There should be two values, correct? Yeah, this is correct. Okay. Oh man. Is this okay? Okay. All right. So, yeah. Is everybody okay? So we, right, we have the y predicted. All we got to do is first we do the reshape, then do the difference, and then do the difference square, and then do the summation. So we will get this, and then we will divide. So then we will divide each value by delta, right? We have to divide each value by delta, isn't it? Okay. So this is the error. Oh, we have to subtract the overall error. Just give me a moment. Give me a moment. What I'm trying to do. Okay. All right. Okay. So we have to first compute the loss. That is the important part. Okay. So we have to first compute the loss and then compute the gradients. Okay. We have to first compute the loss, compute the gradient. For now, I'm just parking the loss function aside. We will talk about this in a moment. Okay. Because we are going to compute the okay. All right. All right. Hmm. Okay. Just give me a moment. I'm trying to think. Okay. Yeah. So, all right. All right. So first we'll compute the loss here. Okay. Computing the loss is pretty simple. I'm just we'll talk about the loss function later. First, we will just code it here. Okay. How much is the loss given these weights? We have W's. So we will first of all compute the loss just like that, right? And okay. All right. Okay. Where is, yes. All right. So first of all, what we did was we added 1 to x1. That's going to be common. Fine. Right. Now, okay. The loss before before increasing W's, right? So what's a loss before increasing W? Pretty simple. Okay. Right? The loss before increasing W is going to be a scalar value, correct? It's going to be scalar value. Okay. How much is that? X1. And okay. So each instance is multiply with W. Okay. And yeah. I'm just thinking like, should I do this? Okay. This is my X, right? And this is my W. Okay. If I do W dot transpose and do X at, okay, W dot transpose, okay, W dot reshape, okay. All right. What am I trying to do? Okay. This is how my W looks like right now. This is how W looks like. And if I do bring it to down like this, okay, okay, it would be this one. And okay, what you want to do is take this value, do the dot product with W do dot reshape. Okay, I'm going to convert it into this. Okay, and okay. What? So X has these many values. Fine. Oh, I have to do X1. Sorry. Yeah, I have to do X1. Here. It's my w dot reshape. Okay. Yeah, I think this should be okay. This is essentially, okay, for each of the instances, we have calculated this. So okay. All right, this is how it is. Yes, now it makes sense. All right, so like this. All right, now here we go. So we basically added 1 to this. And what we are trying to do is we are taking the W. Okay, we are saying, okay, this is a W which is reshaped such that there is only one column. And then we are saying NP, okay, right, the delta, okay, Y predicted is equal to X1 into W, right? That's the one that we did here. Okay. Yeah. X1 dot W dot reshape, and that's it. W dot reshape. Okay. Yes, this should do the job. So we got, yes, this is good. Now, what we have done is we are saying this is our Y predicted. Okay. This is our Y predicted. And right, the error is equal to Y predicted minus Y predicted, right? So the predicted value of Y has right, that thing. So we are again reshaping this second one such that there is this, and then the loss is going to be error square, and then we'll say np dot sum. Okay, that's it. Am I making sense? Yes, no. Okay. So and then we will do the second part where this is the way we calculated here, right? What all did we do? We did quite a few things. Okay. Yes, this is how we calculated the new weights. Okay. Now, loss after increasing W. Okay, that's our loss after increasing W. Okay, and going up. Okay. Yeah, so that's our new one. And then we are doing this one, right? Okay, so that's about it. And we will basically do the same thing over and over. Where is that? Yeah. So this is my new weights, just like the previous one. I am computing the overall loss, right? And all I've got to do is, this is my new weights after modifying them tiny bit. Okay. And that's it. And y predicted, this is my new error. Okay. And I'll call it loss 1. This was my loss. And that should be okay. And then here I'm saying return loss 1 minus loss divided by epsilon. I'll call it epsilon. That's a general terminology to use for this. And okay. Honestly, I'm not confident if it'll work. Okay. So compute the gradient. It doesn't mean, I'm just removing this loss function for now. Okay. X, Y, and W. Okay. X, Y, and W. Okay. So it has done something. I don't know what it has done. All right. So we will continue from here next time. Okay. So yes, this one should have returned multiple values. Okay. This one should have returned multiple values. Remember what we did here when we were computing the difference? X equals 0. We are supposed to pass x equals 0. Yes. How many values are there? Okay. All right. Let's see. Okay. What's the value of W? Yes. So you can see that the shape, essentially it has returned the gradients for the value, right? So we computed the gradients, we got the gradient, we got the gradients with respect to each of the W. Okay. All right. I just need to figure out, these values seems crazy, so I need to figure out what's going on here. Okay. So probably we'll continue from here next time. And yes. Okay. All right. We'll continue from here next time, and we will basically try to see if we can generalize, because this logic and this logic is same, right? And therefore we can basically just figure out what is needed to to get this done. Okay, so we'll try to generalize this in the next session, but I would say that all of you are requested to try to implement the gradient descent using the NumPy. It's much more easier. It's just that I am not very I'm more conversant with Python, but it's a good exercise, because everywhere you will find that we, instead of writing for loop, you usually use the the OS given, or the framework provided multiplication. So you see that we converted the for loop into matrix multiplications, for loops into the dot products, and that's what we have done everywhere. Okay, so I would want everybody to try their best to come up with the compute gradient method, and once we have done that, rest of the things are simple. Correct? Is everybody okay?
Sure.
Yes, Sandeep.
Yes, sir.
All right. So yeah. So you will notice that we have not used a single for loop, and we have just utilized the functionalities given by NumPy. Okay. So see you next week at the same time. I would want everybody to just pull up the NumPy and start implementing it. The core part we have already implemented here. Okay. I'm going to just commit it right away before I forget. August 30. Okay. Um,
We share the recording link also. Send it.
Sure. Okay. So the mechanism that we have followed is kind of very straightforward. Okay. And I think there are just very tiny mistakes. We can slowly, work upon that. Okay. So, all right, git add. Okay, git commit. Okay, I've committed this notebook, and I expect everybody to start tinkering around. It's very much needed. Okay, it's very much needed. I would want everybody to start tinkering around, and I request everybody to just try to implement the gradients using the NumPy. Okay, the core logic I have already coded, and I would want everybody to just work on it, fix the code, and make it work. All right. So yes, I'll see you next week. I don't want to just get into, teaching you NumPy functions, because what happens is that you basically will forget everything. You will not learn anything. Okay, because when you see the implementation of, say, ChatGPT model towards the end, you'll find that basically the entire thing is essentially just dot product and matrix implications. That's all. Okay. And yeah, make yourself super comfortable with both matrix implication and dot product in NumPy. Okay. So and the logic that when you are working on it, my request to all of you is, whatever you are trying to implement, the way I was breaking it down into parts, just try. What happens if I give two-dimensional array? What happens when I give three-dimensional array? And then keep on implementing and go slowly, and you will be able to derive everything. Okay, so yeah, so I would request everybody to go like this. Most of the logic that I have shown you would remain exactly same, just minor fixes need to be done. Okay, so see you next week at the same time. Again, please implement it by yourself. Okay, this is the most critical part. Rest of the machine learning is piece of cake for all of you. I can guarantee that part. Okay, I can guarantee that part. This is something, something that I would want my PhD candidates, those who basically are doing PhD and want to work with me. I would want everybody, like the guys who were working from IT Bombay, who were like the research scholars who were working with me, and I had to ask them to, hey, just go to the basics, implement this in Python and NumPy, then we will talk. Okay. They had finished their MTech, they had finished all the machine learning courses, but they did not have any idea about how to implement gradient descent. And that becomes a very big bottleneck, because if you are working on the edge, when you're working on the algorithms and model, it kind of I would not, I specifically if you are in a research project or somebody is in a research project, I will not accept that person until they can implement their own gradient descent. Okay, so now this kind of exercise also teach you multiple things. Like earlier when we implemented gradient descent, you learned a lot about function passing and doing all of the, like the differential calculus using Python. So that taught you multiple things. And this one is teaching you how to utilize the loop nature of NumPy. Why do you need looping? That's another question that you might ask, that what's wrong with using for loops, right? Now, here's a very important part. Okay. So when we are using, let's say, matrix multiplication symbol, at symbol, and right, the framework that you're using underneath, it will figure out when to use GPU, when not to use GPU. Okay. But if you are writing for loops, the framework doesn't know how to parallelize it. Okay, like the reason NVIDIA GPU are so popular and powerful and is going, everybody is using them, is because the code of TensorFlow is written in this format. Okay, underneath, so you are delegating the task of matrix multiplication to GPU, and GPU is parallelly multiplying. Okay, for W1, it sends the processing to one processor, for W2 to another, W3 to another. So that way, it's kind of distributing the task of matrix multiplication to multiple CPUs, and therefore, this approach is incredibly fast. If you use for loop, GPUs cannot figure out when to distribute, what to do with that. Okay, because you are writing for loop, you are expecting it to be sequential. But if you let the underneath system decide upon it, so the implementation of TensorFlow's matrix multiplication is much more efficient than what we will do, and it utilizes the multiple processors and so on. So that's the reason why this way of doing the work is better. And in general, you avoid for loop even in data processing. If you are, let's say, doing big data. What is big data? Big data is utilizing multiple computers in order to do your work, right? If everywhere you are writing your logic such that all the data comes to one machine, then you do it, then it's not going to work. If you are doing the for loop, for each record in this file, do that. Instead, you write your function, hand it over to the framework that run this function on all the nodes, and it's your duty. That is a better way. So everywhere when you use the for loop, one of the problems that you create is you are telling the system that you want to go sequentially stepwise. Okay. And therefore, the data need to be brought in together here, and this is what you want, right? But if you utilize the framework, like in case of MapReduce for the data engineering, when you utilize the MapReduce framework, you basically delegate that for loop to the system, and you just stay focused on what you want at the end of the day. Okay, so again, it's important. This is the efficient version of what we have done, efficient version of gradient descent on top of what we had done earlier. Okay, so this exercise answers a number of questions for you. Like you might say that, okay, what's the point of using TensorFlow? What's the point of using NumPy? What's the point of using Scikit-Learn? What's the point of using any of these frameworks? It also answers your question that how does the systems utilize the GPUs? Can my program, if I run my program and run it on GPU, will it be fast? No, unless and until you are utilizing the framework. If you are writing for loop, normal for loop, reading one record at a time and doing the processing, your program is going to be as slow as it's on your laptop. It's going to be as slow on GPU as it's on your laptop. So there won't be any difference. So this kind of exercise would answer a number of questions for you. Okay, so yeah, see you next week, and go through this recording, go through the notebook, and work on it. Okay, and it's a humble request, because this is something that changes you as individual. It forces you to get out of comfort zone. Okay, see you next week.
Thank you.